1.8 from section 1.1. You're given this function h of p. A little bit weird that p is the input. More standard input would be the letter x, but this is just making the point that you can use other letters if you feel like it. And you're asked to solve for h of p equals 3. Other ways this question could be asked would be find all values of p so that h of p equals 3. The important thing for you to figure out when you see this question is that this 3 right here is the output, not the input. It is not asking you to find h of 3. It's not asking you to evaluate this thing right here. That's not what it's asking you to do. It's asking you to figure out what the input, p, must be to make the output equal to 3. So you're over here, you're looking at the blueprint, you're like, the output is p squared plus 2p. So the output is p squared plus 2p. And I'm trying to figure out when that thing right there equals 3. So solve this equation. The thing that's really from this chapter, or this section, I guess, is getting to here, right? Knowing that you have to solve this for p. That's all from this section. To solve this for p, it's not easy. It relies on this thing called factoring, which you should learn in a different section. I'll make videos at some point on that. To solve this equation, you want to isolate p, essentially. And maybe you're like, yeah, subtract 2p from both sides and then take the square root. That's great, except then you'd have p's in your answer. And you want to solve for p so that it's not in terms of p. So the only way you can do that, well, the most efficient way to do that is to factor. It only helps to factor if you have something set equal to 0. So the first thing I'm going to do is subtract 3 from both sides of the equation. Note that I could have factored out a p here to rewrite the left-hand side as p times p plus 2 equals 3. But it doesn't help to have something times something equals 3. It only helps to have something times something equals 0. And I'll touch on that a bit more when I get there. So the first thing you want to do is subtract 3 from both sides. That gets you here. Then you want to factor the left-hand side. I won't give you a whole rundown on factoring here. The basic idea is that when your leading coefficient is a 1, you're looking for two numbers that multiply to the constant term, which is -3, and add to the coefficient on the linear term, in other words, +2. So what two numbers multiply to give me -3 and add to give me +2? Well, let's see, +3 and -1 would work. Right? 3 times -1 is -3, and 3 plus -1 is +2. So what that's saying is this quadratic equation, or expression, I guess if I'm just looking at the left-hand side, factors into this, that this is equal to this. If you're not sure about that, the nice thing about factoring is you can always check your answers by multiplying these things back together. FOIL might be an acronym you're familiar with. After you factor it, and the reason I subtracted 3 from the start is I now have something times something else equals 0. The first something is p plus 3. The second something is p minus 1, and that equals 0. And it's important that it equals 0. If it doesn't equal 0, that doesn't tell you anything. But if you're multiplying together two numbers and your answer is 0, you know with certainty that either the first number is 0 or the second number is 0. That either p plus 3 equals 0 or p minus 1 equals 0. That's a very valuable property of multiplication and the number 0 that only works for the number 0. So people get so trained to just jump from this step to this step, they don't think about why it works. But the reason why it works, if you understand that, it'll prevent you from making mistakes where you try to factor when you're not equal to 0. Because if this were equal to 5, for example, there's lots of things I can multiply together and get equal to 5. It doesn't give me any information about either of these two factors. If it equals 0, that tells me that either this is 0 or this is 0. So what I've done is I've taken one kind of complicated equation here, a quadratic equation, and turned it into two easier linear equations. And so I'll just solve each of these individually. If p plus 3 equals 0, I could isolate p by subtracting 3 from both sides of the equation. And if p minus 1 equals 0, I could isolate p by adding 1 to both sides of the equation. So I come up with two different solutions, -3 and +1. So it says, given this function, solve for h of p equals 3. I don't really like the way they worded that. I would have preferred they said, given the function h of p equals p squared plus 2p, find all values of p so that h of p equals 3. And then my answer would be p equals -3 and p equals +1. So I'll call that good.